Hi students, so today we're going to be engaging in squares and cubes. Our end result will be, at the end of this week, to be evaluating expressions with radical exponents. Before we do that, I want to discuss previous topics that we've seen before in the past. So if we look at a square, okay, and I asked you to solve for the area of this square, you all would tell me, well, let's go ahead and look at these sides, and I know that this side here, okay, because it's a square, would have to be equivalent to this side here. So to solve for that area, y'all would tell me that that would be x times x. Cool. If we knew those values, you guys already know that we just multiply those together. In this case, though, we've got variables. So we would represent that as x to the 1 times x to the 1. So how would we solve for our final answer for this? Well, we have these 1 values here in the exponents. So we already know, using the product rule, that when we take these exponents, we have this m to the n times some m to the, we can say p, that's going to be m to the n plus p. In other words, we need to add the exponents. Cool. So when we add these exponents, we're going to say we're going to have 1 plus 1, which would equal to 2. So we get x squared. Well, x squared, okay, or x to the power of 2. So in other words, when we square something, we're simply multiplying that value by itself. So if we said x times x, you would say x squared. If we were going to square 2, you would say 2 times 2, which is 2 squared. If we said 10 times 10, well, that's 10 squared, and so on and so forth. You could even say y times y, which is y squared. That's where we get the term squares from. Okay? Well, let's discuss cubes today. So if we talked about cubes, well, what does that mean exactly? Well, it's the same thing as squares, right? Except in this case, instead of dealing with a two-dimensional figure, we'd be dealing with a three-dimensional figure. So if I asked you to solve for the volume of a cube, okay, what does that mean? Well, if we have a cube, we already know that all of our sides of this cube have to be of equal measure. So we'd say that this side, our base, would also have to be the same value of our height here, which would also be the same value of our depth. So you would say base times height times depth, right? So when you use these values here, you're going to say x times x times x. Using the same rules, we know that we have a power of 1 for each one of our exponents here. We're going to use that same product rule to where we're going to be adding up all of our exponents. So we would say 1 plus 1 plus 1 equals 3. So we'd say the volume here would be x to the third. And the important value here is this 3 here in the exponent part. This is, you guys have heard math teachers in the past say, well, this would be x to the third. This would also be x cubed. So we get these terms looking at the volume of a cube, and that's where we get these terms from. And so if I asked you to solve for, let's say, 2 cubed, well, that's the same thing as 2 times 2 times 2. Well, 2 times 2 would give us 4, times the 2 that we bring down here would give us 8. If we talked about 3 cubed, well, that would give us 3 times 3 times 3. Well, we know that 3 times 3 is 9, times the 3 that we bring down here would give us 27. All right, so let's go ahead and discuss this next table here. So I'm going to go ahead and provide you guys, and you can see it in the files folder on our team site, just a breakdown of our square roots and cube roots. And so you can see here that 1 squared is 1 times 1 is 1. And the opposite of that is the square root of that. And we'll be discussing square roots and cube roots in just a bit. So what does that mean? Okay. But this is a chart that I would want you guys to use. Please refrain from using calculators at this moment. I know some of y'all don't have access to calculators, so I want to make sure that you guys have the essential tools so we can look at these integer operations as far as squares, cubes, square roots, and cube roots. So let's talk about square roots. Okay, so we already know that when we square something, that's going to be some value times itself, right? Well, what about a square root? Well, we're looking to solve for what this value is using opposite operations. And so what this would look like is we would see x, and we square root this here. Now there's actually a little bit of a number that goes right here. We don't identify this number as far as square roots, but there's actually a little imaginary 2 here. And this number here would be our index value. But as far as square roots, we just kind of leave that blank. So you don't need to remember that for this part here. But when we talk about cube roots, it's going to be important. So we're talking about the square root of some type of value. Okay? So if I give you some situation as far as the square root of 4. What is the square root of 4? So what we're looking for is we're looking for what 2 numbers multiply give us 4 here. I know a lot of you guys are already saying it's 2, it's 2. Yeah, and that'd be absolutely correct. But how does that work? Okay, so we could say here the square root of 4, okay, is the same thing as 2 times 2. Okay, which is the same thing as saying 2 squared. Okay, tomorrow we'll be discussing how to write square roots and cube roots and whatnot as far as exponential, rational exponentials. But for right now, what you guys need to understand here is square roots and squares will simplify. We'll dig into this more tomorrow. But in other words, we're able to simplify these two out here, and we're left with 2. So you could say the square root of 4 equals 2, based off of this principle here. Let's try that with another number. Let's do the square root of 16. Well, what 2 numbers give us 16? Okay, well, 2 times 2 is 4. That doesn't work. 3 times 3 is 9. Doesn't work. 4 times 4 is 16. Okay. So let's do that here. It is the square root of 4 times 4. That means that we're actually getting 4 squared, and the square root, and squares simplify out, leaving us with that the square root of 16 is equal to 4. Okay, very cool. Alright, well, let's talk about cube roots then. If I said I wanted to solve for the cube root of 8, well, we can rewrite this as the cube root of 2 times 2 times 2. And we're looking for 3 values here because we're discussing cube roots. Remember, when we're discussing cube roots, we're looking at a cube. And more importantly, we're looking at that volume. So we need 3 repeats. Okay, so we've got here. Well, 2 times 2, we know is 4 times 2 is 8. That works. So what we can see here is we've got that cube root of 2 cubed. Okay. Well, like we discussed as far as squares and square roots, we know that the index value here, okay, will simplify out with our value here. And again, we'll discuss more into this tomorrow. All you guys need to know for right now is that these would be eliminating out, and so you're left with that the cube root of 8 is equal to 2. How does this work as far as variables are concerned? Okay, so let's say I asked you to solve for the square root of x squared. Okay, well, x squared means what? We would have x times x, right? So we could say the square root of x squared. We know that these would simplify out, and we're left with x. If we did the same thing with cubes, we could say the cube root of x cubed, and these values would simplify out, and you're left with x. In terms of operations. Tomorrow, we will be discussing what happens if we have something as far as like x to the 6th, and I want to take the square root of that. Okay, we'll be digging more into how do we turn this radical symbol into a fractional exponent, and we'll discuss power rule more tomorrow. So I hope this video helps today, guys. In the files folder, actually in your notebook, you'll see other videos that I've attached. Not my videos, but videos that will help refresh your memory as far as exponents and roots and cube roots are concerned. Hopefully this video helps. If you have any questions, we'll see you all on my office hours. Y'all have a good day. Thank you.